Before moving into more complicated features of object-oriented programming, such as inheritance and polymorphism, it is a good idea to ensure you have a solid foundation on the basics of class design and implementation. First, remember that a class is a group of related data and the methods that manipulate that data. A simple class, such as the person class, which we'll add right now, can be made up of many individual attributes or properties. These properties can be automatic properties. In other words, they have no backing fields, such as this last name. Property. So anytime you create an object of type person, you have direct access to this last name property. But we can also create fields, such as this ID field, and then create a property to encapsulate that field. We can select Quick Actions and Encapsulate Field. And now we have a fully defined property that allows us to manipulate this ID underscore ID field. The reason we would use properties instead of fields is that a property such as this, which is actually compiled into two separate methods, a setID method and a getID method, it allows us to, first of all, in the mutator, the set part of the property, it allows us to prevent invalid data from being set to the underscore ID field. Right now, we are simply taking the value passed into the mutator and assigning it directly to ID, so there is no validation going on. However, if we knew that the ID must be greater than 0 and less than this series of 9s, we have 9 9s, if that is the legitimate range of values for the ID field, then we are ensuring with this if statement that invalid data will not be set. In the event that we are given invalid data, it is typically most appropriate to throw an exception. In this case, an argument out of range exception would be the appropriate exception to throw, and we'll supply the parameter name and a message. The parameter name would be ID, and the message would be ID must be between 1 and that value. As a matter of fact, I think we allow that upper end value, so I should make that a less than or equal to. And we can also get rid of the underscore here because they are actually accessing the ID property, not the field directly. So it would be more appropriate to label the parameter as ID. Returning the ID can be done just this simply. We don't have to worry about checking the range when returning it because we only allow this possible range between 1 and this value to ever be set. Now, because we have this logic in place in the property, we should always access the underscore ID field through the property and never directly. Even the constructors should obey this rule. Let's create that constructor now, public person, and it's going to accept an ID, and so far just a last name. We'll add more in just a bit. Now, when we set ID, we are going to do it using the ID property, not underscore ID, and that'll be equal to the little ID parameter that's passed to the constructor. And the same will happen for last name as such. For every other property, you must decide what is appropriate. Do we need to have data validation or not? In this case, last name does not have any data validation, and we probably will not have data validation for first name either. If, however, you've decided or decide later on that we are not going to allow empty or null strings into last name or first name, then you would want to change these properties from the auto property technique to the standard property technique like ID. And because we are using properties to begin with and not fields, changing it from the auto property to a fully fleshed out property such as this does not break binary compatibility. This is also another reason why we would opt to use auto properties instead of direct field access, even though we are achieving very similar results. Now we would probably want to add first name to our constructor and assign a value appropriately to the first name property. Next, a person may also be associated with a gender. It really depends on where this person class is going to be utilized. Every industry will have its own definition of what a person is. For instance, a person to the Department of Motor Vehicles would be a different person than to Amazon or some other online retailer. There will be different pieces of information associated with these person objects. We will assume for this example that it's just going to be a very generic person, not used for any particular industry. So we're not going to add values or attributes to this particular class other than the ones that make perfect sense for a generic person. So let's take a look at how we would implement a gender for this particular person class. Since gender typically takes on two possible values, male or female, we will create possibly an enum to represent the different values. We can define the enum either within the person class or at the same level as the person class, which means they would be sibling types. It all depends on whether or not we anticipate using this gender in any other part of our application other than within this person class itself. I will define it outside of the person class, and I'll just do it in the same file. If I have a lot of enums in a particular project, I will typically create a standalone C# file that contains all of the enums together. That way I have one place to look for them. But since we're only going to utilize this gender enum initially, let's just keep it together with the person class. And we'll call it public enum genders. Now, there are different schools of thought as to how to name an enum. Some people like the physical name enum, such as this, gender enum. Some people like to call it something like gender types or gender kinds. But in this case, I am just going to leave it as genders. And with enums, it's always a good idea to start with an unknown or an unset value, which corresponds to the default value of an enum, which is 0. So we'll say unknown is 0, and then alphabetically female comes next, then male. I do not actually need to say equals 0. It is implied. Anytime you define an enum, the first value in the enum is always 0, and every value afterwards is just 1 plus that previous value. So female is 1 and male is 2 automatically. Now I can define a private field of type genders. And I'll follow the same pattern where I define it as _gender. And you may also put default values with your fields, such as 0 for the ID, and gender we can also specify unknown. Those will be the default values assigned. However, C# doesn't like you using variables until they are actually assigned to. So it sometimes is a good idea to provide a default value, even if it's going to be the same one provided by the compiler. Now you can also define default values for automatic properties if you wish, as such. That way we can be complete and consistent in our definitions. So it would probably help to include a genders parameter to our constructor now. And I don't actually have the property defined yet. As you can see, it has the red underscore under gender. So I could right click on it, quick actions, and generate it as such. And I'm going to move it to the same location I have the other custom property. And I actually usually like to have my auto properties above the custom properties. Now on this one, it's a good idea to make sure before you assign a value to the gender field that it is actually one of the possible values. Because enums, even though when you use IntelliSense it restricts the list that it displays, there is nothing that restricts you from putting, let's say, the value of 4 in our gender, even though we only have 0, 1, and 2. So it's a good idea to make sure that the value is actually defined by using the enum.isDefined method, and you supply type of your enum, which is genders, and then the value that's passed in. And if it is defined, then we allow the assignment. Otherwise, we will again throw an exception. This time, the parameter name is gender, and gender must be one of the values defined in the genders enum. Now let's add a date of birth. We could again use an auto property for this, or if we require data validation, we could use a custom property. If our application is to restrict date of birth to a date prior to the current date and time, then we would require a custom property, and we will take that approach. So private date time. Date time is the appropriate data type to use, and we can assign to it datetime.minValue just to give it something in its assignment here. And then we'll go ahead and create the property for it. And our data check will be if value is less than datetime.now, then we allow the assignment. Now, this is an interesting concept as well, because this definition of what is a legal date of birth changes based on when the program is run. So, for instance, if today was January 1st, 2015, then I would not allow any dates of birth that would be after that, such as January 31st, 2015. But if it's February 1st, 2015, now that previously illegal value would be legal because the date has changed. So this is something of a moving target. And there's nothing wrong with this. However, it is something you have to keep in mind. The other rules we have are pretty static in their definitions. So it's either part of the gender's enum for gender, or the ID has to be between these two values. If this person was to be used in the context of a database, we'd probably have to have an additional check to make sure that that ID has not yet been used as well. Okay, so if the value for date of birth is less than now, then we assign it. Otherwise, we will once again have to throw an exception and say date of birth must be earlier than the current time. Now this could get interesting if you were, let's say, working at an obstetrics office where you are planning for dates of birth in the future for future babies, and in that case the rule for that date of birth would have to be different. Maybe then the rule would be it can't be anything greater than 9 months or 10 months from the current date, just to give yourself a safe margin. So let's also add date of birth as an input parameter for the constructor. And notice every single one of these assignments goes through the properties. We never actually go directly to the fields unless we are in the property itself. So right now this is a good definition for a person. Definitely there are more things we could add, and we'll get to a few more items shortly. But before we do that, let's take a look at how we can utilize this person. We can create a person from our main function by saying person p equals new person. And then since we only have one constructor defined, remember anytime you define any constructor in a class, the default constructor that is automatically provided by the compiler will then disappear. If you want that default constructor back, in other words the parameterless one, you have to do that manually. So let's go ahead and provide, we don't want to say int ID, let's just say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we need to supply a last name, a first name, a gender, and a date of birth. And the easiest way to do that is typically using the datetime parse method, where you can type in a date as a string and it will convert that to a legitimate date time. Then we can use console write line to output this person information, and we can use custom formatting for the ID so it looks like a social security number. We'll pick p.lastname, and then we will constrain that to, actually it's not constrained, but it'll be left justified 15 characters. If it's actually a 20 character last name, that -15 will have no effect because it will not truncate. Let's also give 15 characters for the first name. Then we can supply the gender. And if we go back to the definition here, we can see that the longest gender is unknown, which is 7 characters. So we'll make that -7 for left justified 7 characters. And then finally, the date of birth, which we'll do in year, month, day format. When we run the application, it will then print the information appropriately. As was mentioned earlier, a class is an organization of like data, where like means related data, and the methods to manipulate that data. So far, our person has several pieces of information such as an ID, first and last name, a gender, and a date of birth. And we have properties to govern all of those particular fields. And let's actually do some organization here real quick to make this code a little easier to work with. So I'll put a region around the fields, and I'll put a region around the properties. And the end region directive does not actually require a comment, but I like to see it that way. When I'm at the end region, I don't have to guess which region it's referring to. Then I can minimize those regions, and then I can also create a region for the constructors. Well, what about methods to manipulate the data contained within this class? Well, we do have an interesting property called date of birth that tells us when someone was born. But because, as we know, the date of birth is a fixed value, but the current date and time is not, the age of a person is a moving target. Therefore, it's not a good idea to necessarily provide it as a piece of state information. Rather, the age should be calculated as needed. So let's go ahead and create a method that calculates someone's age. We can call it getAge, and then we would come up with some formula to return the age of a person. Well, we know we're going to have two pieces of information to calculate someone's age. First, we are going to need the current date and time, which you can get from datetime.now. Then we need to calculate the number of years that have elapsed between the date of birth and the current time. And we could say now.year minus the date of birth dot year. However, this alone is not sufficient to calculate an age, because we also have to take into account the current day and month as compared to the date of birth's day and month. So we need to do a test to see if the month, the current month, is less than the date of birth's month, or if the current month is equal to the date of birth's month and the current day is less than the date of birth's day. Then we have to make sure we have enough closing parentheses here. Then what we need to do is remove 1 year from our years calculation. Now the minus can occur either before or after. This is always marginally faster, just the way the compiler deals with it, but it really doesn't matter when it's on a line all by itself. And then we can return years. We can utilize that calculation within our console write line statement by putting the age in parentheses right after the date of birth, maybe. So we could say p.getAge. And with string interpolation is definitely legal to make function calls within an escape sequence such as this. But we probably want to limit it to 3 characters. We run this again, we should see the person's age. What would happen if we wanted to create another person that shares most of the same information as this existing person P? Well, we would have to call another constructor. We'd say person P1 or P2 is equal to new person, and then provide it basically all the same values of P, but with whatever changes we need to make. However, there's another technique we can use, and it's a special type of constructor, and it's known as a copy constructor. And it looks, as far as the constructor call, very similar to a typical constructor, except the only parameter is of the same data type as the class it's being defined in. So we have the person constructor in the person class accepts a person object. And by convention, most people call the other object other. This technique is also known as cloning, and you can utilize the iClonable interface to indicate that you do support that capability. For a cloned object, what I'm going to do is copy all of the assignments from the other constructor, and instead of saying ID is equal to the little ID coming in, the ID we want is coming from the other person. So we'll say other.id. And I will utilize that same other dot syntax for the other values, but notice here I still have to correct for the spelling difference because the parameters are all camel case while the properties are proper or Pascal cased. Now if I want to make a copy of a person, I just have to call this constructor, passing it the person I wish to copy. So I could create another person. Person P2 is equal to new person, and then I can supply P as the parameter. Then I can copy the console write line statement that we had used for P, and then modify this to show all of P2's values. And I'm going to use the same console write line statement because everything will line up nicely. So when I run this, it looks like we printed the same exact values twice. And in fact, we did, but that was through the cloning of the P variable into P2. We could, of course, have changed some of the values. Like we could change the last name to Williams, and then we could change the first name to Jane, and therefore we'd also want to change the gender, most likely. Then if we run this, you will see they are in fact different records. However, this is becoming tedious. Every time we wish to print a person out, we're having to duplicate the same code essentially, and only changing the prefix used or the handle used to get to the individual properties we wish to output. So instead of this, what I'd like to propose is encapsulating this into a different method. You can right-click, and then you can select Quick Actions, and then say Extract Method. Now notice the new method is called New Method. We'll call it Print Person. And now every time I wish to print a person, I just have to call print person and pass it P. And notice here it changed nothing in the console write line. It just still uses P, but it did create a parameter to the method called person P, so we can pass that information along. So I can take that print person P and change the second console write line to also utilize that method. And now, as you can see, everything is still identical as far as the output's concerned. But this starts to become an interesting problem for object-oriented programming, because this print person may be better suited to be contained within the person class itself rather than external. Now, this is not a cut and dry scenario, and here's why. When you define classes such as this person class, otherwise known as a model, you typically want to separate different facets of the program from each other. This model should be strictly responsible for maintaining the data of a person object. Printing to the console, as we've done here, is a very specific task, and it, in a way, couples the person class to a console application, even though we theoretically could just ignore any console printing methods if we were to utilize the person class in, let's say, a WinForm or web application. So it really comes down to a philosophical debate whether it is best to include this method with the class itself or keep it external, or maybe even create a separate utility class or a helper class for person that is specific for console applications. And that is a decision that there is no one correct answer. It is going to always be based on a lot of people's personal feelings of the situation, as well as your current circumstances in the project that you're writing. If I did wish to include it into the person class, I could simply copy that method, and I'll get rid of the print portion or the person portion of the print person method because it's kind of redundant. We are in a person. And I would also remove static because static implies it only works on the class as a whole, not on a particular instance of a class. And for this method, it definitely works on an instance of a particular person. And I also do not need to provide a parameter. The reason is, when it's called, it will already be within the context of a person object, so I don't have to pass one in. But I do need to remove the p dot prefix from each of these property and method accessors because there's no reason to use p dot anymore because, again, we are within the context of a person. So when it prints this ID, it is going to be the ID of the current person or the person that the method print was called upon. So going back here, I could comment out the print person methods and say p.print instead. And we also better make this public, by the way, otherwise it's not accessible. So if we go back to person, it has to be public, it doesn't return a value, it's just called print. Then when we run, again, we have the exact same results. Another aspect we didn't really consider for this particular class is that maybe the ID should not be changed once it has been assigned. So when you are born in the United States, you are given a Social Security number. And unless there are some very interesting extenuating circumstances, you will keep that number until the day you die. So it may make sense not to allow this set mutator to be called after the constructor has finished its work. There are several ways we could do that. We could make the entire property read-only. That's one technique. Or we could also simply make the mutator private, and now the only place that we can actually assign a value to the ID field would be through internal methods of this class itself. I could not, for instance, change this person's ID after the fact because the ID mutator is inaccessible. But that raises an interesting problem because we technically have two people now with the same ID. In this situation, you may end up with having to create a very specialized method, and we'll call it change ID. And its entire purpose is to change the ID. Now, it really doesn't accomplish anything different than if we allowed the mutator to be accessible. We could, in fact, turn off that private mutator and make it public again and remove this method. But this has specific implications. We are creating an explicit method called change ID, which has different connotations than just setting the property of the ID. So then I can go back out to the program main method, and I can't set ID directly that way, but I can go up to the change ID method and change it as such. Now, if I run this, you will see that the ID has actually changed. But that could lead to yet another problem. Notice here we have full visibility of someone's, we're assuming, is their social security number. And in most environments, that is a big no-no. Even in the Social Security office, I don't know if they have the ability to see the full number without you first telling it to them. So we may want to add another method completely instead of having this ID property exposing the ID in its full form. We'll add another method so we can only see it in its partial form, in other words, the last 4 digits. So we could make this entire property private. This still works because ID is accessible from within the class, but if I go back out to program here, we are no longer able to print the person's ID as such. That's just not allowed anymore because that ID property is now completely inaccessible. So what can I do to fix this? Well, we can either add another method which extracts the last 4 digits, or we could add a separate property and only have it return the formatted ID, in other words, just the last 4 digits. So let's go ahead and take the property approach. We'll say public, and we'll make it a string this time instead of an int, because we're going to do some pre-formatting to it that will have characters that are not legitimate for an int. We'll call it get. Instead of get, we'll just call it formatted ID. It doesn't make any sense to call it get formatted ID because that is going to be implied by using the get accessor. And since we're only going to have a get, this is technically a read-only property. So what can I do? Well, the first thing I want to do is I want to extract the last 4 digits of the person's social security number. But to do that, I need to convert it to a string first, because if they have a value of 1 for their ID, it's only 1 digit, and I kind of need to fill in a few extra zeros in front to make it look like a legitimate ID. So first I'm going to create an ID string, and I will assign to it the ID, calling it toString, and I will format it with 9 zeros. So if it's a 1 for the ID, the integer value, then it'll give us 8 zeros, then a 1. If it's a fully formed social security number without any leading zeros, then it will give me just those 9 digits. Well, now that I know I have at least 9 digits, I can start using some string manipulation techniques to extract those last 4 digits. So I could say string last 4 is equal to ID, and then I want to use the substring method, and I need to pass to it the location of, or the index of, this particular digit right here, so I can get the last 4 of these. So if I know the length is 9, let's not assume it's 9. Let's say somehow an invalid ID got stuck in here. We can't assume it's 9, but we can always use the length of the string. So I could say id.length, which will typically be 9. But if I need this index right here, if this is 9, then what index do I need? This is index 0, 1, 2, 3, 4, index 5. So to get to index 5, I would need to subtract 4 from the length. And that makes logical sense. We need the last 4 digits. I just wanted to step you through the thought process of trying to figure out which starting point that is. Now, substring will, if it's not given an explicit length of characters to retrieve, will just retrieve the remaining characters from the string, and that's sufficient. And now I can return a new interpolated string. Instead of zeros, let's use xxx dash xx dash, and then last 4. So formatted ID is what we want to use instead of ID, even in this print method and externally here. So hopefully now when we print or run this, you'll see that it only returns the last 4 digits, and we never see the entire Social Security number anymore. If you feel that this example was clear to you and something you could reproduce on your own, then you are in a good position to advance into the more complicated topics, such as working with interfaces, composition, inheritance, and polymorphism. Those topics will round out your knowledge of object-oriented programming and really put you in a new level of capabilities. One thing to remember, however, is don't forget the basics. Just because the techniques that you are going to learn in the future are more complicated, it does not excuse you from utilizing best practices and understanding how the different pieces of a program are put together. Classes are good for very specific purposes, like creating these encapsulated data models, but they can also be useful for non-data related tasks as well, by creating static classes that allow you to create a library of functions that don't require a specific instance of a class to call them. This is very similar to the console class, which you call methods on all the time. But there are other techniques as well that will just build upon what you've learned so far and what was demonstrated in this particular example.